Okay, so these are my video solutions for the two pulley problems on the Unit 4 quiz. Of the two pulley problems, one had involved friction, this one here, and the other one didn't. So I'll probably start with this one, even though it had more parts, just because it was simpler, because it didn't have that weird variable. So I was actually a little confused toward the beginning, and I didn't realize that the two problems were going to be part of it, so I didn't take down all the exact numbers, but I luckily had an entire page where I was working out my problems, so I have most of the information, probably enough to work through it anyways. So basically, there was a pulley hanging on this side, and using the force equation here, which is really helpful, I found out that the weight downwards multiplying by gravity gave this a pulling force of about 88.2 newtons, pulling these two blocks upwards, which were connected by a wire. And together, the sum of these two masses were about 10 kilograms. And again, using the force formula, pulls downward at about 98 newtons. But you can't exactly figure out what the acceleration vertically is pulling this way with just this. So you can find out exactly how much it's pulling this way by using this this downward force to the sine of the angle here, which is sine 30. So 98 times sine of 30 gives you 49 newtons, pulling the opposite direction from 88.2. So the difference between these two values, 39.2, is the force that's pushing these two and the block that was hanging on this side to the right and down. So using this this force pulling this way, we can reverse the formula to find acceleration going downwards, which is this is what I had gotten. There's also a tension part of it, but I'm not entirely sure if that's what he wants us to do. But just in case, yeah. So it was 55.6 is the weight pulling from the block that was here and that was here. Which is pulling them off. The wire that was between them had an opposing force, which was the weight of this block alone, which I found using this formula, as if I had these two, but only using this one, which gave me another variable, which was another number, which is 29.4 newtons. So these were pulling the wire in opposite directions, so I added these together and I got my tension for the wire. So on the second one I'm going over, but the first problem regarding this, it was very, very similar, but it involved friction as a factor, which was a bit more complicated. But it was virtually the same thing. You find sine, mg, as you can see here, the force times the sine of theta, which was 20 degrees here in this point, going downward, and here it was 19.6 newtons pulling upwards, given the weight of the block that was on that side. And here, the difference between the normal force, which is important because we're using friction, and the downward force has an angle to it, because the normal force goes perpendicular to the ramp, while mg force still goes downward, true. So we can find the difference here using force to the cosine of the angle that's created. So essentially you can use that to calculate friction, and right off the bat we could rule out two of the answers that were below the weight of the opposing cube, or rather, with the friction force of the opposing cube, we can rule out the two lower values. So I think they were both 3 point something. So I'm trying to think. I think I used I selected the lower of the two 3 values, because I'd found out the block would obviously have to be more if it was moving, or if it was going to stay still. So of the 2 values, I'd pick the lower one, because it was figuring out which of the two the block would remain still the lower value. So that's how I figured out the problem. I think it was correct.